Good morning, everyone. Maagham na araw sa ating lahat. So, once again, I am Engineer Aunhel Adoptante, Science Research Specialist 1 and Project Technical Co-Lead of the iTANONG project under the DOST-ASTI. So, today I'll be presenting a paper that has been published in ACL entitled iTANONG-DS, a collection of benchmark datasets for downstream natural language processing tasks on select Philippine languages. Now, just to give you a briefer, while the Philippines has a lot of or uses a lot of languages in its more than 7,000 islands, Tagalog and Cebuano come out as two of the most prominent and widely used languages in the country. Although it is very much used in our everyday lives by the people of the Philippines, there are still there's still so little data available that can be used for training AI models, particularly large language models. As you all know, if you're familiar with the different large language models existing right now, OpenAI's GPT 3.5, 4, Mistral, Llama, these large language models are trained upon thousands of text and averaging on around terabytes of data, text data on certain languages. So even though we are currently using Tagalog or Filipino and Cebuano in the Philippines, the amount of text data available in the internet are very minimal. That's why we are still considered a low resource language in the AI community. There are actually already existing datasets. Wikitext and Oscar present a collection of Filipino, Tagalog, Cebuano datasets. However, they fail to capture the certain linguistic nuances and the occurring evolution of our languages, especially in what we call code switching. Switching is a linguistic phenomenon in which we switch from one language to another. For example, ganito, nagpe-present ako and then bigla ako mag-switch into English in a very seamless manner. Pero kaya ko rin bumalik into Tagalog. So, very few languages or datasets cater to those linguistic nuances. And in fact, these is also one of the prominent research areas of natural language processing in general, code switching. So, as part of our initiative in iTANONG and in DOST to cater and to, trailblaze AI research here in the Philippines, we curated a set of benchmark datasets for different natural language processing tasks that include code switch text and cater to the said linguistic nuances. So the scope of this presentation would be how we gathered our data, the pre-processing that we did to make sure these data are clean and suitable for training, our sentiment analysis dataset, part of speech tagging dataset, named entity recognition dataset, some word embedding models that we've also trained and developed, as well as pre-trained language models. Now for the data gathering part, we have collected a multitude of articles, of news articles, open source stories in Tagalog, Cebuano, Taglish. We also did social media posts that are open source that we are authorized and we have the we are authorized to use, meaning there is no copyright. And these are categorized into two, formal and informal. So formal means formal literature such as research papers, books, And then informal caters to the informal, informal sources, stories, social media engagements, things like that. Then these, the table one shows the total amount of lines gathered per language, so around 5.1 million lines of formal Tagalog text and around 200,000 Cebuano text, and then more than 3 million lines of Tagalog informal text and almost 2 million lines of informal Cebuano text. Now, given that these were gathered or organized from different sources, we had to do some sort of pre-processing to make sure that these are in our context clean data. So we utilized a pre-processing technique used in the work of Velasco et al. In 2022. So we, for the emojis, for the line breaks, URLs, these have corresponding replacements to make sure, not just to make sure that the data is clean, but to also cater to the pattern, or to make sure that everything is in the correct pattern. So for the sentiment analysis dataset, we implemented this topic modeling technique called latent directlet allocation, or LDA, to construct the dataset. So it helped us identify relevant topics within the dataset or within our corpus, ensuring diversity. And then we randomly selected 9,000 sentences from 3 LDA identified languages. Also take note that during our pre-processing, these lines of text have varying lengths. So some phrases or some sentences could be as short as 2 or 3 words, 3 tokens, and some could even reach into paragraphs. So what we did is we only utilized, or we filtered our collected data to make sure that all of the data that we have exceeded at least 3 tokens. Okay. And then upon selecting the 9,000 sentences, we used the OpenAI's GPT 3.5 model to classify 500 phrases into positive, negative, and neutral. And then we used embedding a sentence transformer to generate embeddings of these classifications to check or to capture its nuances. And then we used these embeddings as features for label propagation. So in totality, we have around 3 data sets. So we have a balanced data set of 3,000 each for positive, negative, and neutral. Then 2 unbalanced data sets as shown in the table. So the rationale behind this is there are advantages when you have a balanced data set. That is I think, what we strive for. We want to train our models in our data that is balanced. However, we also cater to those unbalanced data sets for other researchers. Then for post tagging, or parts of speech tagging, we adapted a model called SMT Post. And then this model was selected as it achieved a higher score of 84.7%. And then in totality, for the word statistics, there were a total of around 71,000 number of words with a vocabulary size of 15,600. Minimum words per sequence was 6, and then a maximum of words per sequence was 26. The dataset exhibited a total count of 3,868 unique parts of speech patterns. And then to get a clearer observation, we extracted the trigrams of each sequence and calculated the frequency distribution of the corresponding post tags. So the most common pattern that recorded on our dataset was FW, 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 which means a foreign word, as tagged by SMT post with more than 2,300 occurrences. For NER, or named entity recognition, so we gathered 6,230 data points and used GPT 3.5 model to label the named entity for each word. So for the consistency, we used IOB2 tagging, in which B- was prefixed for the named entity tags where it begins, and I for the subsequent words that are part of the entity. A word that is not named an entity was tagged as O. So here in the figure, we've just shown our prompt on how we did the tagging using GPT 3.5. The researchers, again, we used GPT 3.5, so we ran it at a low temperature of 0.1 to attain a realistic and predictable set of labels. A total of around 143,000 named entities were identified by the model with 6 unique classifications. So the most common was the O tag with almost 125,000 counts. Then we also developed or present a collection of word embeddings in 2 techniques, word-to-vec and fast text. The most common techniques in word embeddings. So these are offered in, again, word-to-vec and fast text, and also in for word-to-vec and fast text, it is available in skipgram and continuous bag of words, with vector sizes ranging from as small as 20 and as large as 300, available in .txt and .bin formats. The team has also conducted pre-training of multiple BERT language models the remaining unlabeled data in both Tagalog and Cebuano. So we just did a 80-20 data split. We trained the model on 80% of the data and then tested it on 20% of the remaining data. We also, in the noteworthy development, the authors pre-trained a BERT Cebuano model. This initiative, to the best of our knowledge at that time, was the first ever attempt to train a BERT-based language model exclusively for Cebuano. So we were helped with, some of our interns were actually speak Cebuano, so they were big help in the development of these language models. For the performance of these models in BERT and Roberta, the validation perplexity, or the amount of surprise, or the metrics that we use to get the performance of these models, the lower the better. So for Tagalog, it's around 8.3. For Cebuano BERT, it's 52.36. Then for Roberta Tagalog, 9.4, and then for Roberta Cebuano, 52.30, around 52.38. For a more detailed explanation, or if you want to further read our paper, it is already available online on the link flashed on your screens. And yeah, this concludes my presentation. Thank you very much for listening.
Thank you very much, Engineer Adoptante. So are there any questions, clarifications from the audience? Okay, so, well, perhaps I have one which is similar to the first speaker. What would be the immediate application of the data set that you have researched?
Yeah, the main advantage, or the main contribution of this paper is we wanted to provide a benchmark data set for the use of the Filipino researchers on AI and natural language processing. Say you want, most of the benchmark data sets available online or used only cater to the big languages, English, Spanish, French. But given that Tagalog, Filipino, or Cebuano are counted as low research languages, these benchmark datasets will help our researchers benchmark the performances of their languages, thus enhancing the capability and the capability of Tagalog-based and Cebuano-based researches or language models.
Okay. So, thank you so much, Engineer Adoptante. And we would like to present to you the Certificate of Appreciation for sharing your invaluable insight and work on iTANONG-DS, a collection of benchmark datasets for downstream NLP tasks on selected or select Philippine languages during the NichiCon 2024. Given this day, 19th day of July, at Novotel, Manila, Quezon City, Philippines. Signed by Dr. Andrew Tria, Director of UP EEI.